My name is Shravani Joshi. My roll number is 175. Our topic name is surface tension with expression on liquid droplet and halo bubble. I am explaining surface tension. The tensile force acting on surface of liquid in contact with air or gas. It is denoted by sigma symbol. SI unit Newton per meter, MKS unit kg per meter. Molecular basic blood molecules attracted equally on all directions. Surface molecules experience an unbalanced downward net force creating surface tension. It is diagram of surface tension.
Hello sir, my name is Shubham Dokade. I am explaining surface tension of the liquid droplet. To find the internal pressure in the liquid droplet, we consider the liquid droplet of diameter d. We cut the droplet into half, and two forces acting on the liquid droplet. One is tensile force and second is pressure force. First, tensile force is equal to sigma into circumference of liquid droplet, which is pi d, and second is pressure force. Pressure force is equal to P into pi by 4 d square. The equating expression, pressure force is equal to tensile force. Then we can calculate the pressure force, internal pressure force, by dividing the area. Dividing the area into this side, we can calculate the internal pressure. Two forces acting on the liquid droplet. One is across the cross section of area, which is tensile force, and second is surface tension, which is act on the circumference of the liquid droplet, which is pi d. Thanks.
My name is Vivek Mirekar. Today I am explaining surface tension of hollow bubble. The hollow bubble differs because it has two surfaces which is in contact with air. One is outside and another one is inside. The key differences of hollow bubble is the tensile force is double. The tensile force is double because there are two concentric forces which resist the internal pressure of the hollow bubble. The equilibrium equation of the hollow bubble is P into pi by 4 d square is equal to 2 into bracket sigma into pi d. The final expression after resolving this equation we get P is equal to 8 into sigma divided by d. Thank you. This is the diagram of the hollow bubble. It is the diagram of hollow bubble. Change in pressure is equal to 8 into sigma divided by d.
Hello everyone, my name is Vishwanath, having roll number 174. Today I am explaining the outcome of after studying the liquid droplet and hollow bubble section. In that, first rule states that nature prefers the always sphere. Means the liquid droplet always will meet the spherical shape. How? Because the tension can pull that all liquid elements towards the force. That's why the liquid cannot form the pyramid or any another shapes. Sphere is the smallest size of that liquid element. This is the first rule. And second one is the smaller bubble and the higher pressure. This came from this equation. Here you can see that change in pressure is inversely proportional to the radius. As the radius increases, the pressure goes on decreases. This we can see in real world. While blowing the balloon, then we can see that as balloon is in normal state, to blow the balloon we require the more pressure. As the balloon is blown up, then we require very negligible pressure. And third one is the surfactants. Means as here we can consider the soap or the detergents. How? When we pour the water over the dirty clothes, then the water doesn't shrink to the clothes. Then we can add the detergent as the installer of those liquid elements to inside the clothes. That's why these detergents or soap act as a gap closer. Result, it lower the surface tension. Means we can push the water inside the clothes. That's why the surface tension is reduced.
My name is Sujay Pawar and my roll number is 173. I will tell the conclusion of surface tension. Surface tension causes spherical shape of droplets. Internal pressure is inversely proportional to the radius. Smaller bubbles have higher internal pressures. Bubble pressure is twice that of a droplet at the same radius. Surface tension creates the internal pressure. To maintain the curved surface, a hollow bubble has a double the excess pressure of a liquid droplet of the same size, because it possesses two free surfaces instead of one. Other point, surface tension acts as an inverse tension, forming the force on a fluid surface. Due to having a two surface, a hollow soap bubble has twice the pressure of a single surface liquid droplet has the same diameter.